Okay, so we come to these topics now. It's about protein denaturations. You have done previously protein structures. Now it is time to look into deeper, something to do with changes to the proteins once you heat it up or you leave it too long in the freezing storage conditions. This is called denaturation. It is unique to protein. You don't hear there's no such thing as starch denaturation or lipid denaturations. Only proteins can do denaturations. So we know that protein exists naturally in human bodies, in nature as native, more stable, soluble with the polar groups. Imagine this is the original native protein solutions. The inside is supposed to be the hydrophobic groups. Remember, you fold it in order to bury the hydrophobic groups. Therefore, the outside is supposed to be the polar groups. Yeah. However, with the heating, alteration in pH, maybe pressure, maybe oxidation, maybe salts, we cause this denaturations. There is loss in its native conformation. You cause the alterations of the secondary, tertiary, and quaternary structures. This is the reason why I want you to learn the structures of the protein so that you understand what happened to the native proteins when it is denatured. So you cause a lot of changes in the original properties. If the protein is an enzyme, it lost the enzyme function. If it is soluble, it decreases in solubility, increase in viscosity, etc. But as food technologists, our interest is in the functional properties. We use protein to achieve certain functionality in food. Therefore, you must understand the impact of denaturations on protein functionality. Okay, you can recall the part we cover in the food structures. This is the long chains of the polypeptide. It is being stabilized by covalent bond like disulfide here and several others, non-covalent like hydrogen bond, hydrophobic ionic interactions. So because of high temperatures, thermal processing, roasting, cooking, retort cooking, we cause the destabilization of these non-covalent, especially the hydrogen bond. We cannot do anything about the disulfide because it is way too strong. So the destabilization of the non-covalent that hold the protein together, causing the whole structures to be unfolded. So to use the protein for their functional properties, you need to understand some science behind this. Yeah. So to help you, I'm going to use this cake known as angel food cake. It is not meant for us as food technologists to learn baking, but for us to understand it, we have to understand that this particular ingredient here, one of the main ingredients, egg whites. So this particular cake recipe uses egg whites in order to achieve emulsifying, foaming, and also gelation functional properties. So what we did about 12 years ago, there was one student from Thailand. She came here for 3 months. What's her name? Kanyarat K. She was from University of Mae Fah Luang from Thailand. She did research on evaluation of functional properties of egg white obtained from pasteurized shell eggs as ingredients in angel food cake. So the question we ask her is very simple. Can we use this particular pasteurized egg, which is basically what the industry did? They let these whole eggs undergoing pasteurization to kill microorganism, certain level of destruction of microorganism before they sell it to the market. Yeah, this is very different from ordinary unpasteurized egg. So there were two eggs, protein egg white used. One is EWP, unpasteurized. Another one is EWP, which is pasteurized egg white, to make this cake or angel food cake. So we use this particular instrument called differential scanning calorimeter, DSC, that measures the temperatures of denaturations somewhere there, and also measure the how much enthalpy, the energy required to cause the denaturations. So the higher the values, meaning the more native protein inside this particular egg. So you can see here the EWP has higher temperatures of denaturation and higher enthalpies of denaturation, and EWP had lower temperatures of denaturation and lower denaturation enthalpies. So we concluded from here that there was definitely a partial loss of protein structure during the pasteurization of EWP. So to test whether this particular denaturation had caused any alteration in the functional properties, so one functional properties we tested were emulsifying properties here. The higher the values indicated by the parameters there as function of time, the higher is the emulsifying properties. So from here it was figure 2 indicated that EWP indeed had lower emulsifying properties. Other than emulsifying properties, we also tested for other functional properties of protein like forming, texture, and volume of the cake. So in this case, the first table we displayed there is forming stability. I mean, how many percent is a stability? It was evident that EWP has lower forming stability, and for textural properties of the egg white gel, we indicated that EWP had higher hardness of the gel. This is because the eggs already pasteurized, so the process of forming the gels has started much earlier compared to the EWP. Anyway, we do not want the cake to be too hard. We want it to be soft, right? So that is reflected in the volume of the cake. When we made the cake, we measure the volume in terms of milliliter. EWP indicated a lower volume compared to EWP cake. So that's an indication already. And then finally, we did hardness here. As you can see, EWP displayed lower hardness, I mean softer cake, compared to EWP that is too hard for a normal cake to be. And then finally, quite important also, because we need to know the panelists' opinion after they consume the cake. So yes, there are appearance, odor and flavor, but we want you to focus on the texture. In terms of texture, what is preferred in terms of texture? And panelists agreed that the texture of EWP, the fresh eggs, was better. Maybe it is softer. And in terms of overall acceptability, the EWP cake were beaten by the EWP. So you can read this conclusion later from the paper, but I summarize here. It is easier and more straight to the point. 1. EWP was pasteurized as a whole egg compared to EWP was fresh, never pasteurized before. So this causes partial denaturation of most of the egg white proteins in the EWP. So this denaturation causing alteration in the functionalities of the proteins. As food technologists, we want the protein to be undenatured, to be native, before we can use it in cake. Therefore, the main conclusion was that EWP is not suitable ingredient for making angel cake. Okay. Okay, that was about the use of heating or pasteurization, but you must know also that other than heat, freezing can also denature proteins. This is due to the formation of ice crystals during storage a very long time under frozen storage, weakening of hydrophobic interactions. In heating, we mentioned that it was the weakening or loss of the hydrogen bondings, but for freezing, mostly the weakening of hydrophobic interactions. So it's a big industry, this pollock fish, tons and tons of pollock fish were converted into these surimi blocks. This is essentially fish protein here being frozen. So in order for us to use this block of frozen fish, just fish tissue, no bones, nothing else, just the fish tissue, basically it must remain in that native or undenatured state, because if it is already denatured, you cannot mix well with other ingredients. There are many ingredients here. There may be some kind of starches, some kind of flours, flavoring, etc. So it's very important for the industry to keep this frozen surimi intact, undenatured. So the question that I ask is, how do industries solve this problem? That is the kind of question that I will answer in our class. Okay guys, so that's all for now. We'll meet again in the next chapter on protein functionalities. Very relevant to you if you want to be food technologists dealing with especially new product developments or quality assurance. So happy learning. Bye.